this molecule will break. This molecule will break into CH3 minus, and see here, this is electropositive. This is more electropositive. More electropositive. Than carbon. That means carbon is more electronegative. That is why this type of a bond breakage occurs. So you can write CH3 minus plus MgBr plus. MgBr plus. Now see, where will this attack? This will attack this carbon of the CO bond because this is polar. So this is more electrophilic. This carbon is more electrophilic. And see how we write the mechanism of this reaction. Now, write the product form. See, everything else is remaining the same. H here. See, you write the same thing. And look at the arrow. What is the meaning of the arrow? A pair of electrons shifted to the oxygen. So one bond is still remaining there. One bond is still remaining there. The other bond, that is the two electrons of this bond, is getting shifted to the oxygen atom. Now oxygen is already having two bonds here. Two lone pair of electrons. So it gets three lone pair of electrons. So you have the negative charge. And you have the CH3. And what is the counter ion? The counter ion is MgBr plus. And remember, any ion will have a counter ion. So this is going to be. So this is a complex. This complex is soluble in ether. This complex is soluble in ether. Now when you add in water and little ammonium chloride acid and water in HCl, this will get hydrolyzed. H will come here, so this will be protonated, and OH will come here. This is the reaction. This is what is Grignard reaction. CH3, C, I write the same way, CH2OH, ethanol, plus MgBr OH. Okay, so this is the formation of a primary alcohol. Formation of a primary alcohol. What is a primary alcohol? There are two hydrogens here. That is primary alcohol. Now, if you want to form a secondary alcohol, look at this. What you have to do? You have to make one of the hydrogen a CH3. Look carefully. So now look from where this hydrogen has come. It has come from the aldehyde. So you make a change here. Instead of this, you put a CH3 or an R dash. I put an R dash. Okay. So what is the starting material? R dash. I'll put R dash is equal to CH3. R dash equal to CH3. So what should I do? I just put a CH3 instead of H. So CH3. Now what is this molecule? This is an aldehyde. An aldehyde. So there's an aldehyde, and this aldehyde on reaction with the same sequence of reaction will give you a secondary alcohol. I will write the equation if you require it. See here. Let me take CH3 MgBr. CH3 MgBr reacting with CH3 MgBr is negative, MgBr is positive. So this we will attack here. See this, CH3, C, CH3, H, and O MgBr. And now this is treated with H plus or NH4Cl or H2O. You just have to add water. This is highly reactive material. So you will get CH3, CH3, CHOH, isopropyl alcohol. Okay, so primary alcohol from formaldehyde, secondary alcohol from aldehydes, and if you want to make a tertiary alcohol, you have to change this also into CH3. Okay, that means you'll get a ketone. Suppose you start with a ketone. CH3 minus, MgBr plus. I write MgBr here. Now we get that. You can make any alcohol like this. OMGBr plus, okay, OMGBr, O minus MgBr plus. Now react this with water. I'm writing all the sequence. I don't want to assume that you people understand it. You will not write it. I know. Anyway, that's so. This is how you make different alcohols using a Grignard reaction. Okay. Now let us look at little bit details about. So many other methods of making alcohols. Okay, one of the alcohol you can convert. I'll give another example for an alcohol synthesis. You can reduce an ester using lithium aluminum hydride, LiAlH4. It's a reducing agent. LiAlH4. This will give you, what you have to do is see here. You break here and reduce it. You get CH3, CH2OH plus. This side is also forming an alcohol. Same thing. 2 molecules of ethyl alcohol. 2 moles ethanol. Now see here you have, here also there are 2 carbon, here are also 2 carbon. Therefore you are getting same alcohols on either side of the ester. So what is actually happening is this is first getting hydrolyzed into carboxylic acid. Carboxylic acid is getting reduced into alcohol. Okay, so that is what. Again, a method you can use even any carboxylic acid, CH3, C double bond O, OH. Again, lithium aluminum hydride. Okay, will give you carboxylic acid. Okay, so these are the methods of making different alcohols. Now let us look at the manufacture of simple ethanol. The most widely used material probably, and much of it is going into abuse, that is for drinking purpose. So drinking with potential, inverted commas. Now you have different quality of different types of alcohols. Alcohols have a different grade. Okay, alcohols are different grade. You call wash, then you have rectified spirit, then you have absolute alcohol. Absolute alcohol, right? Now, actually, wash will contain about 8 to 10% of alcohol. 8 to 10%. While your rectified spirit will be 95.6 alcohol. 95.6. And absolute alcohol, it is nearly 99%. Okay. Now, normally it is 99.5%. It is absolutely, because it's very difficult to prepare 100% alcohol, because alcohol is highly hygroscopic, it will absorb moisture very fast. So 100%. So this is called absolute alcohol. Now, what is the method of manufacture? It should be very cheap method, otherwise it will not be viable to drink. Okay, alcohol is manufactured with the cheapest raw material possible. Okay, you must be knowing what it is. It is made from molasses. Molasses is a substance which is left behind after isolation of sugar. Substance, you must have studied all these things. Substance left behind after isolation of sugar. From cane sugar fermentation. Okay, subsequently we will use mother liquor. Mother liquor left behind after the isolation of sugar from cane sugar. Okay, that means cane sugar. This is pressed. Press it. Okay, it is totally pressed to isolate the cane sugar. The sugar, the juice, cane sugar juice. Cane sugar juice, which we generally drink. You know that. Okay. Now this is concentrated. Concentrated under vacuum. Concentrated, you get a concentrate. You get a concentrate of cane sugar, and this is crystallized. Okay, the crystals of sugar crystals are separated. Sugar crystals are separated. Okay, are separated in the mass and then filtered. The filtrate, so here you get sugar, And here you will get filtrate. This filtrate is known as molasses. Okay, all maximum amount of sugar is separated from this, and what is left behind is molasses. No, it's an industrial waste. No more sugar you can isolate from here. That is why it is getting wasted. So this is taken and subjected to fermentation. Okay, it's a good old process. You must be knowing it. People have been drinking for years. Sorry, what should I say? Ages. Drinking has become was a habit for ages together. Different. Actually, all these were obtained by fermentation of different fruits. Okay, right now fermentation of this using yeast, very common. Okay, you know what is yeast? So you add yeast, and the fermentation is done for 2 to 3 days. So what happens is, what is the chemical reaction? You have the cane sugar, which is C22, sorry, C12, C12H22O11. This is cane sugar. This is cane sugar. Now this is reacted with when you add yeast, what you will get is invertase. Invertase. Okay. Yeah, invertase will convert this into a molecule of glucose C6H12O6 plus a molecule of fructose. Remember, both are having same molecular formula. So this is glucose. Now the glucose will get converted into, one second. Yeah, glucose is getting converted into ethanol. By an enzyme called zymase. Zymase. Both of them, both glucose and fructose get fermented into ethanol plus carbon dioxide. And this is the same process which you are doing in your chicken in your kitchen when you are using preparing what is that, dosha or vallapam. Okay, same process. That is why you get a lot of carbon dioxide. Lot of carbon dioxide is coming out. Okay, so that is the chemistry behind. That means all your vallapam will be containing a lot of alcohol, right? So you are, is it allowed? But what happens is when you're heating this, it will get evaporated out. That's all. Now let us look at denaturation of alcohol. Denaturation of alcohol. Now alcohol, if it is the one which we are obtaining by this, the alcohol which is obtained by this, that will be containing 8 to 10% of alcohol, and that is what is called water. Okay, and this, and for preventing people from drinking this, especially those which are going for industrial purpose, this alcohol is mixed with poisonous material like methanol or pyridine to prevent drinking, unauthorized drinking. And remember, it's a poison. Okay, we are familiar with Madhya Durandam. It is due to the drinking of denatured spirit. Okay, so these are the substances, and they also add some color, like a small amount of copper sulfate is also added to give a color to the denatured spirit. Okay, so this is what is meant by denatured spirit. Now, so this is now I told you this after this isolation of this 8%, 8 to 9%, what you have to do is you take this wash and distill. What is meant by distillation? Evaporation followed by condensation. Evaporation and condensation. This is what is called distillation. You evaporate and condense it in your separate flask. So you will get 96.4%, 95% for how much I wrote it here. Now 95.6%, 95.6% down. So that means 95.6% of ethanol plus the remaining 4.4% of water. This mixture will come out. Mixture. This mixture distills out. And that is called rectified spirit. So simple distillation will give only this mixture. Further purification by distillation is not possible. It's not possible. Hence, we call this as an azeotropic mixture. Azeotropic mixture. And it will be having boiling point less than both of the components, less than 69 degrees Celsius. 69 degrees Celsius is the boiling point of ethanol. And 100 is the boiling point of water. So it is having a boiling point less than 69 degrees. So azeotropic mixtures, low boiling mixtures, having a definite composition. Remember, this composition is constant. So they will be having a boiling point less than 69. The boiling point will be lower than any of the components. Okay. So this is what is called an azeotropic mixture. This is a binary mixture. Remember, it's a binary mixture, binary azeotrope. So you know what is the meaning of the word azeotrope now. Azeotrope. Okay. So that is now. Now alcohols, now we look at the physical and chemical properties. I think by that time it will be over. Anyway, let me go ahead. One more word, power alcohol. Alcohol can be used in motor vehicles as fuel. Used in motor vehicles as fuel. And such alcohol, in certain countries, they are using it. Of course, they use not along with other fuels to increase octane rating.